Our next subject, we're going back to our 3 conveyor system, and we're going to take our code and move it into subroutines. We're going to organize it. Now the code's going to function 100% identical to the way it did before. We put it in subroutines and then later into programs to isolate different chunks of it for ease of troubleshooting and ease of referencing. So let's take a look at what we did in the lab project. Challenge 1, Part 5. We are continuing with Challenge 1, and Part 5 involves organizing your code into subroutines. We had you open your last Just for Fun project, Challenge 1, which was Part 4, Grease, but we had you label it Grease, and save it as Challenge Part 5. So you see up here we have, I say Part 3 Grease, could be Part 4. But anyway, the word Grease was the important part. So I'm going to save as, and I'm just going to make this Part 5 so it matches the manual. And we'll just throw in a 00 just in case we want to have multiple versions. The main routine has grown to a size that is cumbersome for screen captures. For this reason, we're going to introduce a new subject, creating subroutines. This feature of RSLogix 5, RSLogix 500, and RSLogix 5000 is analogous to taking a book that is written on one continuous length of paper to a book that has pages and chapters. It's a organization of the code. It doesn't necessarily change the code or change how it operates, how it executes. It's strictly a way to organize it for easier troubleshooting and maintenance. I decided to go to subroutines because it's getting fairly untidy and unruly on the screen. But in reality, your reasons would be different, but you would still end up with the same result. Whenever you organize, you first have to create categories or containers in which to separate objects of similar type. So we had to go to Main Program, right-click, New Routine, name it Conveyors, and click OK. You could also choose the type. Now this is strictly going to be ladder diagram. There were several options, as you can see, of which programming language, etc., and to which program to attach the subroutine to and its assignment. These are of interest in a later volume of this series. We're not going to discuss them right now. I had you repeat that process. Main Program, New Routine, and this one we named Lubrication. And accepted it. So you see we're creating these subroutines. Notice the main routine has a little white sheet of paper on it that's dog-eared with a 1 on it. And by the way, at this point, if you go to Main Program, go to Properties, Configuration, and go to Main, you can make any one of these the main routine. Now we're not going to do that. We're going to leave the main routine the main routine. And remember that those names, I created these 2 names. You can edit this name. You can go to Properties. See, you can change that name. We're going to leave it main routine though. We now have 3 separate routines. One of them is the main routine and all the others are subroutines, no exceptions. But can any of these routines be designated the main routine? Yes, they can. We just showed you that. So the name does not necessarily say that it's the main routine. And in the manual, I show you how to do that. What is the difference between the main routine and any other routine within the same program? Primarily, the main routine is the only routine that runs automatically in that program. and all other routines have to be called or to say jumped to using a JSR instruction. As our program stands right now, if there was any logic in conveyors or lubrication routines, it would not execute because there is no means to get to it. There is no method. My code started a little bit different than yours did. Roughly, this is page 225, 226 in your lab project manual. My reset rungs down here, these 3 rungs to reset the loop schedule timers, the RTOs, I had them with their respective areas. I just moved them down to the bottom. Also remember that I also have motor conveyor 3 with its lube, and I have it controlled by internal bits. In other words, they're not alias to actual module defined tags. So I have that logic in here too, these 2 rungs. You don't have those 2 rungs. Or rather to say, you may not have conveyor 3 in your code. The 2 rungs associated with conveyor 3, motor conveyor 3, and the loop solenoid. There's no module defined tags associated here, and you may not have this 3rd rung in here that resets that loop schedule. And you may not have these 2 rungs in there that you actually toggle the buttons with. So for right now, don't worry about those. In the lab manual, I said with rung 1 and 3 selected, which would be this rung and then control 3, that rung, I had you copy these 2 rungs to the clipboard. I'm going to modify that a little because I'm going to grab motor conveyor 3 with it. So hold down the control key again and pick that. So I have 1, 3, and 5 picked. And I'm going to do a control C to copy those. Then I'm going to open up the conveyors tab. Control V. I'll delete that empty rung. And now you see I have all 3 conveyors in the conveyors routine. In the manual, I said double click on conveyors to open it, then control V, which we did. Press enter and then delete the incomplete rung 0. Then go back to the main routine and delete those same 2 rungs that you just copy and moved into a different routine. So we go back to main routine. And by the way, you can double click to get back and forth, or you can go to the tabs on the bottom. Once you have more than one routine open, you can go back to the main routine here. Now notice that those 3 are still selected. So the focus of Windows right now is on those 3 rungs of logic. So if I hit delete, it deletes those 3. If I go back to conveyors, they're still in there. So we haven't lost any logic. We temporarily had a duplicate of those rungs in conveyors that were in main routine, and then we went back and deleted those. So now we select the main routine at the bottom and then delete those rungs. Now remember, in the manual we're talking about 2 rungs. Here we're talking about 3 rungs, because I never deleted motor conveyor 3, because you will eventually add it back in and alias it to something. Now we could have cut and pasted those 2 rungs, but this sequence is much safer, just in case you have an accident with your mouse on the way to paste them. If you cut them and then never actually paste them, you could lose them. This leaves the main routine with 1 rung of logic to enable the system. To verify what I've told you, and that's not entirely true, but we'll just follow the manual. Download this project and go online in the run mode with all inputs off. Before we do that, I'm going to go back to the main routine and look at what else we have. We have these 2 rungs down here that operate the buttons on conveyor 3. I would probably move these 3 rungs right here. We'll go with these 3 into lubrication. So for right now, we'll do what the manual says. Communications, who active, processors identified, download. This is Ethernet, so it's quicker. Download, downloading, and done. Change back to remote run mode. Go to the run mode with all inputs off. So I have to go through and turn them all off. And open the conveyors routine, stop system push button in the on state, toggle start system button on. Well, this is in the main routine, not in the conveyors routine. And we already have conveyors open. But in the main routine, input 1 has to be on. Okay, that's the stop push button. And then in the conveyors routine, we need 3 on and we need 5 on, because those are the stop buttons. Okay, so we need to set this up like it would be if we were using normally closed push buttons. We go back to the main routine and we push the button for 0. Now the system is enabled. In the conveyors routine, is the system enabled bit in the on state? Yes, it is. Okay, let's make sure that all of your stop conveyor push buttons, whatever this instruction is, that it's true. In the case of these, we're simulating these to be normally closed push buttons, this one as well. In the normal relaxed state of the system, those stop push buttons would be reflected in the logic as being true. In other words, not stopped. While observing the logic, switch both start conveyor 1 and start conveyor 2 push buttons to the on state. That would be start conveyor 1 is 2, start conveyor 2 is 4. 2 and 4 on, and then we can go 2 and 4 off, and then let's toggle this one. See, it did go on and then back off, but notice that nothing happened. And there's a good reason for that. We're demonstrating something. This is actually quite interesting, especially if you have the same relative state at your lab station for these 2 rungs in the conveyor subroutine, or 3 rungs. Notice in the instance when I moved the rungs that the 2 timer instructions appear to be enabled. They are not actually enabled, but were left this way when copied and pasted from the main routine. In other words, that last execution of both timer data types was that they were enabled, so those 2 bits are still on in the controller's memory, which is totally isolated from the logic. If the logic doesn't execute, the state of the memory stays the same. We refer to this as data table carnage. Not the first time we've addressed this. This was my screen capture in the manual. If you don't have the manual, you're not seeing this. This was my screen capture. If your instructions are not enabled at this step, not to worry. Continue on. And you can see on the screen here, mine are not. What I experienced in the manual and what I'm experiencing right here on the screen right now in front of you are not the same thing. But at the time that I wrote the manual, that data table carnage found its way into that routine. So in other words, I moved the logic when the program wasn't running. And when I moved it, the state of those bits in the data table stayed the same even though I moved the logic. Put it in the run mode, the logic is not running because there's no JSRs. So there is nothing to instruct those instances of timer data types to clear. Okay, looking here, if I turn on input 2 and input 4, and this one I can't hold on because remember I have that temporary logic that turns it on and back off. But in the manual, it asks you, do the rungs look true? Do these rungs right here look true? This one and this one, 0 and 1. Do they look true? Yes. Is the logic setting the output bits to the on state? Well, does it look like it? No. Are the timers accumulating? No. Just for grins, I see some data table carnage there. I'm going to hit the reset button, which I think is 2. Yeah, we'll go back to main routine. Well, that was in the previous lab. So they would have to be done. This is more data table carnage. You see, these rungs aren't true. Those bits aren't done. So we go look in conveyors at this. It's not done, and we have no way to reset it unless I'm going to click there and type in 0. we carried over that number when we copied and pasted rungs from one routine to the other. So back where we were at. The last question was, are the timers accumulating? No, they're not, even though those two rungs look true. To further prove this detail, select the main routine tab at the bottom of the logic, add a new rung with one JSR instruction. So we go to the main routine, we go down to the bottom, and we add a rung. I'll just type in JSR enter. That puts in a JSR. Double click, and I'm going to pick conveyors. The rung is happy, finalize all edits. Now the instant that it finalized all edits, go back to the conveyors, and you see now they're accumulating. At least these are. I'll toggle that bit to put that one on, and see now they're all accumulating. Notice though that when the RTOs are done, which they do what they're supposed to, the logic back in the main routine, these three rungs right here are resetting those. The RTO instructions should have began incrementing the value of the accumulate member for those instances of timer data types. When they time out, what should happen? Done bit comes on, it resets the timers, and they start over. Did the logic behave as it did in the original Grease Just for Fun program? Yes, it did. However, I did ask the question, why did it not behave as expected? Well, it behaved as expected once you put in the JSR. You would have to qualify that question. Now, if you had trouble with that question, I apologize for that. So you could say, why did it not behave as you expected? The only thing that occurred in this process was when you first put them in the conveyor's routine and then ran the program, the logic didn't execute because there was no JSR. Add a second JSR in the main routine addressed to lubrication. And it's already highlighted, so you can go Control-C, Control-V, double-click on conveyors, drop-down pick lubrication. Now, in my case, I haven't added anything in the lubrication subroutine. I'm going to go ahead and do that. I'm going to go up here, and I'm going to pick rung 1, which is conveyor 1 loop solenoid. I'm going to go down to the reset for conveyor 3 loop schedule. I'm going to go shift, and I'm going to select 6. Now all of those rungs 1 through 6 are selected. I'm going to do a Control-C, then I'm going to double click on lubrication, delete that unused rung, and then do Control-V. That puts all of these in that subroutine. Of course, because I'm online, I do have to finalize all edits, which is not a problem. I have the lubrication routine running as well. Okay, switch all conveyor start push buttons to the off state. Okay, we go back to conveyors. This one we have to do by toggling it, and then we simply switch off 3 and 5. Now you may notice another variation, and that is for my stop conveyor push buttons, I have true if off instructions. I don't think I ask you to do that, even though that's what I've done in the lab manual. So I think at this point I'll change that to avoid any further confusion. And you'll see that it really doesn't make any difference. I'm going to double click, backspace O. Double click, backspace O. Double click, backspace O. Finalize all edits. Now remember that we had 3 and 5, these were true if on instructions, and so we just flip the toggles on to simulate normally closed push buttons. However, down here, that's a little bit of a horse of a different color, because if I put on the system enable, go to main routine, and by the way, I need to delete these because I moved them into lubrication. So if I go up here and turn on input 0, it doesn't start because system 1 push button is off. So we'll turn that on so we can start the system enabled. Go back to the conveyors. Okay, this is a true if off, which means it's off right now. Now personally, I think that's confusing because it doesn't line up with normally closed push buttons. But I hope you understand what I'm doing here. Now remember, we're in a just for fun challenge, so we're going all over the place. We're just exploring. This is not a fixed one way to do it. Oh, you did it wrong, you did it right thing. Our goal here is that these are the stop push buttons. With the way they are right now, we would have to, this is input 3, it's off right now. I would have to turn it on to simulate the stop. Well, we don't want to normally open like that. That's normally open. We don't want normally open. So I'm going to change these back. Edit mode. And this one I'm going to change back because the logic isn't going to work correctly, because remember, we have specialized logic. That is why I was using normally open here, and then I would just turn on input 3 and 5 to simulate stop buttons that were normally closed. Remember, normally closed contact is closed when it's relaxed, not being pressed. No one's pushing the stop buttons right now, so those bits should be on and the instructions should be true. And if you push the start push button, input 2, it starts the motor and it starts accumulating. If you do the stop, which is 3, off and back on, it stops. Now we're going to continue with our challenge 1. We're continuing with part 5. If you want to name it part 6, that's up to you. I think I'm going to save it. I might add, at this point, I mean, we're nearing the end of this manual. We have covered all the instructions we're going to cover somewhat in this manual. Now we're just exercising them. Regardless of what I'm doing, you need to be able to follow along whether I make a mistake or I do something different. Right now we're not in the lockstep mode. It's every man for himself right now. However, we will tidy it up. Before we're done, we'll have the code in a form that works, and you should be able to make yours work if you followed the manual. The first thing I had you do, it's roughly page 232, 233, something like that, challenge 1 continued, part 5, is go to the offline mode, because you can't do this, what we're going to do. Go to motor conveyor 1, go to lubrication, go to conveyor 1 loop solenoid, right click, edit properties, change it to a base. We can no longer afford to use our precious outputs for the loop solenoids. Okay, so you see absolutely no module defined tags in the lubrication routine. I never deleted conveyor 3. So there's a couple pages in the manual where I'm having you copy existing code and then relabel it for conveyor 3. So you end up with 3 conveyors, logic that looks like this. However, the one thing that isn't quite the same, and that is we removed the start and stop. What we're doing, we're taking out the manual function. Part 5, you duplicate the code for conveyor 3, and then on page 234, 235, edit all 3 rungs as shown. These are the 3 rungs. So I'm offline. I can put my mouse here, go delete, delete, delete. I have system enabled motor conveyor 1. If I go here, delete, 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 delete. Okay, that now matches what you see in the manual. And just for grins, I'm going to set these back to 0. We're offline, doesn't matter. So it all looks nice and tidy. However, we do need to alias this to one of the outputs that we freed up. And this is 1, 2, this is bound to be 3. Now you see how the tags are stacking up here and how the local is starting to disappear off the bottom of the list. That's why typically by habit I go to alias, then I type in something to get local, then I drop down. See, now it's at the top. So it's easy then to go in and pick the bit that you want. You don't have to scroll down and then drill down. It's there, you just drill down and you have it. Okay, now return to the lubrication routine and the ease should be gone. You know, once we tidied up our tags, if you have any undefined tags. Now those E's would not have been there for me because I never deleted Conveyor 3, therefore I never put logic in that had undefined tags, just to avoid any confusion here. In the current logic, the conveyor motors will run continuously anytime that the system is enabled. We want to use these conveyors as a part feed buffer into our manufacturing system. That means that we want to put parts onto conveyor 1, one at a time. Have the conveyor run just long enough to pull the part all the way onto the entrance space of the conveyor and then stop and wait for the next part, filling up the conveyor with parts one at a time until it is full. If you didn't shut the conveyor off once the part got onto the entrance, it would just run all the way to the end. We want it to stop as soon as it's all the way on the conveyor. Once the conveyor is full, and as long as the next conveyor is not full, because remember we have 3 conveyors, so conveyor 1, 2, and 3. So once conveyor 1 is full, and as long as conveyor 2 is not full, we want both conveyors to run when the next part reaches the entrance of conveyor 1. Now remember, you have to visualize this. 3 conveyors in your mind. And we'll just picture cartons, corrugated cartons. They come to the entrance of conveyor 1. Conveyor runs until the carton's all the way on, then stops. Next one shows up at the entrance. Conveyor turns on, and then there's 2 on there. Once the conveyor is full, you know, the last carton is pulled on there, the next one that arrives should turn on conveyor 1 and conveyor 2. That way the new arrival gets pulled on to the entrance of conveyor 1. The first one that was on conveyor 1 is now the first one on conveyor 2, and so on. And then we would do the same thing with conveyor 3 when parts are called for. There are 2 methods to determine full: by counting cartons onto and off of each conveyor and specifying a full preset for the counter, or when a carton arrives at the interface between 2 conveyors and the photo eye to the next conveyor senses its presence and determines that the previous conveyor is full. You can do it with counters or you can do it with photo eyes. When conveyor 3 calls for a part, and if both conveyors 1 and 2 are full, and there is another part ready at the entrance of conveyor 1, all 3 will run until the new part is fully onto conveyor 1. At that point, conveyor 1 and 2 will stop, but conveyor 3 will continue to run until that part was pulled onto conveyor 3 and has exited conveyor 3 completely. That would be called a takeaway conveyor. Now you may not like the spelling of takeaway, but I've seen it that way for years, so I'm still using it. Reminds me of a takeaway bag at the hamburger joint. Anyway, we will use photo eyes to determine part positions arriving at the conveyor and pulled onto it when that conveyor's motor is energized. We are currently using 2 inputs for the push button control in the main routine for system enable. Convert the system enable push buttons, at least the stop push button, to a base tag. This will free up another input for use as a simulated photo eye. I'm going to do that. I'm going to go to the main routine. We're offline, right? And I'm going to edit. not create a new. Edit stop system push button. I just set it to base. The alias disappears. And now we have another input that we can free up for using with Photo Eyes. At this point, you should be on page 235, 236 in your manual, and you just converted the stop system push button to a base tag to free up another input for a simulated photo eye. Most of what we're going to talk about you won't see on the screen. If you don't have the manual in front of you, you're going to miss some information. If you don't have your manual in front of you, go get it. Turn to page 235, 236. And on that page you'll see 3 conveyors with some photo eyes, and then you'll see some color graphic representation of 3 types of photo eyes. So pause, get your manual, get to that page, and let's talk. In the manual I have a graphic of the conveyor system that we're using, our imaginary conveyor system. And over the top of it I have an arrow pointing from left to right, showing that's the direction that objects are moving on these 3 conveyor belts. And for conveyor 1, I have local 1 O for output data 1, conveyor 2 local O data 2, and conveyor 3 local 1 O data 3. Each conveyor has an entrance photo eye, the location of which assumes that when a carton comes to rest against the leading edge of that conveyor belt, that the carton is blocking, sensed by the photo eye at the entrance of that conveyor. Meaning that if a carton comes up to conveyor 1, even if conveyor 1 is not running, the leading edge of that carton is far enough into the beam of 1 PE that it is blocked, so 1 PE or local 1I data 1 knows that there's an object there. The physical location of sensors is always an important criteria when writing a control program. Can't tell you how many times that I was shown a diagram, I wrote the program, I got out to the field to commission the system, and the photo eyes were not where they were shown in the diagram. And that does change how you write your program. So first you see if you can adjust the photo eyes to the position that matches what you'd considered in your program. If you can't, then you have to edit your program a little bit, maybe even a lot. Okay, type of photoelectric sensors and placement, as I said, is an extremely important aspect to all control systems that require optical sensing. In the manual I show you the 3 types of photoelectric sensors: through beam, retroreflective, and diffuse. The through beam gives you the most deterministic object sensing because the object blocks the beam as it passes between the transmitter and the receiver, and then the object is sensed. Retroreflective really has 2 beams. The transmitter sends a beam over to a reflector, a special reflector, and it's reflected back to the receiver on the same electronic device. When the object passes between the transmitter and the reflector, the beam is blocked and the object is sensed. Obviously you can see the advantage of retroreflective in that the photo eye, which has a transmitter receiver, has a cable on it, and it electrically has to be routed back to the controller. Where the reflector, it's just a physical object attached at the right point, and you have a bracket so it's adjustable so you can move the reflector to the position that you want. And then of course the diffuse mode. Now in the diffuse mode, the example I show you there are 2 separate diffuse mode photo eyes. So really we're only discussing one of those. The diffuse mode configuration requires that the surface of the object reflect light from the transmitter back to the sensor's receiver. It is also referred to as proximity mode. As the object passes within proximity of the sensor, the light transmitted by the transmitter is reflected off the object and back into the receiver half of the sensor, thereby sensing the object. On the next page, I show you how all three of your routines should look now, and if not, edit them so. I'm going to make my three look like that. In the manual, I show it all on one page, but I show the main routine, and we will geyser this up for your benefit. If you're on a mobile app, there's the main routine, our system start stop, and then our two JSRs. Then the conveyors routine, which has 3 rungs. If the system's enabled, then the conveyors are going to run. We're not online in the run mode. That's why they're not running. And then the RTOs that actually capture the runtime. Now there's another way we can do this. We could create a rung in the lube section that looks at this timer, or rather it looks, we can move these timers into the lubrication subroutine and then do an examine on this bit and do the RTOs, and then this conveyors routine would show system enabled and motors, and that's it. We'll leave it like this for right now. We just want to simplify it some. And then of course in the lubrication, we've got our 3 rungs that give us the pulse for lubrication when the lube schedule timers have timed out, and then of course when the pulse is done, it resets those RTOs. We need to place our photo eyes, and we are limited to 5 inputs remaining. So if you look through here, you do not see any module defined tags. Here you see 3 outputs, and here you see 1 input. That's 0. So we have 1, 2, 3, 4, and 5. So we have 5 left that we can use. We need 1 at the entrance of all 3 conveyors, positioned to sense the leading edge of a part arriving and trailing edge leaving. We can use timers and counters for the remaining sense, so to speak. We would know how long the conveyors are and the surface speed of each conveyor belt, thereby being able to predict exactly where on the belt an object is. Now we're not going to go to that length in this particular challenge, but you could do that. If you know the speed, the surface speed of your conveyor, then, and you know the length of the conveyor, then you can create logic that determines, once it sees the leading edge of the carton, after a certain length of time, the leading edge is going to be at a certain distance from the entrance based on the speed of the conveyor belt and the elapsed time. Just something for you to think about. When you get done with this manual, you could go in and play around with that. Okay, create a new routine and name it production. Consequently, you will need another JSR rung in the main routine. You will also need to open the program tags and delete all of the start-stop tags for the conveyors, including the start-stop pulse timers that we no longer are using. Do not delete the start system push button tag or the stop system push button tag. Don't delete these 2. But I can go into the program tags here, go to edit tags. See, the ones that we wanted are kind of down at the bottom. So there's the stop system push button, system enabled. We want to keep those, and then we want start. We need the lube pulse. We want to keep that. We want motor conveyor, but it's said to delete all of the start stop tags for the conveyor. So Okay, I have this one finished. Now I need two more like this, so I'm going to click there and I'm going to go Control C, Control V, Control V. Now I'm going to go through and change the 1 to a 2, and I'm going to have to do it in all of them. And of course this is not a defined tag, so as soon as I do that, the alias 2 disappears. Okay, now I've changed all the 1s to 2s, and there's many undefined things here. So first we're going to define this tag, which is data 2. Right click, alias. Now L for local, because it's worth doing that now. Look, if you don't, if you just drop down, you see this. So it's worth typing in L for local and then going down and picking, drilling down. Notice that both of these were satisfied as soon as I defined this in one location. Any other location that it exists is defined. Now see, that's an undefined tag, that's an undefined tag, etc. The debounce, there's 3 of them here, so I'm going to define this timer. Timer main program create. That's no longer undefined, nor is that, nor is that. But the count up is undefined. So we'll go in the, because conveyor 2 count is undefined, it's a counter base create. See, now that's a happy rung. So we go to this rung, make this 3. We go through and convert all the 1s to 3s. Now if you had a bunch of these to do, I would suggest that you do one, only copy and paste it once. Because if you have a bunch of these to do, you might lose track of what number you were on. So you could do 1, copy paste, change it to 2, copy paste, that gives you 2 2s. Then you make one of them 3, copy paste, then you have 2 3s. So you have them right together so you can see what you have or you don't have. So we need to define this timer data type and this counter data type. And we're missing something. Photo I. That's aliased, and see how that doesn't, local doesn't even show up there. So you're better off just clicking there and going L, and that brings you down close. I believe it's 3. Let me look and make sure. Yes, it is. Create. Now we have 3 happy rungs. Hopefully when you were doing the projects in this lab manual that you spent some time studying this logic before you actually start to run it. Now in the manual on roughly page 237, 238, something like that, I have the logic works like thus. When the object part, whatever's traveling, breaks the beam of photo I, conveyor 1 entrance, or you could say the conveyor 1 entrance photo I, conveyor 1 debounce begins accumulating for 2 seconds. When you look here, when this goes true, that enables this timer data type to start incrementing in thousandths of a second. Now the reason that we have that timer in there is real simple. It greatly reduces, if not eliminates, false trips on the photo I. We have determined that no object traveling through the system would block the photo I for less than 2 seconds. More likely 3 seconds or more, which means if this isn't blocked for at least 2 seconds, then we're not going to say that it was blocked. It won't get counted. The reason for doing that is because one of your friends trying to be cute might walk by and run his hand through the photo I just to mess up your system. a set of fingers passing through the photo eye or even a hand flashing by would probably be less than a second, 1,000 milliseconds long. When this gets blocked, when this gets turned on, this starts timing. Nothing happens until it's done. And notice that the done bit is in two places. It's here and here. So what happens is, when this timer has timed out and is done, on the next program scan, remember this is still blocked. And we haven't counted up yet. We haven't triggered the count up bit. So this is true because this bit has not went on. It's not 1. But this is now true. So this OR, in other words, photo eye, conveyor 1 inference, or no count up and a debounce done. So this is true. That keeps the timer enabled. So even though it's done, it stays done. The accumulate stays at 2,000. It just sits there until this photo eye, which is this one. In other words, this is true if on, true if off. This is true when the carton clears the photo eye. This is still held on by the not count up and the debounce done. So the timer stays enabled. This stays true, even though this is no longer true when that goes true. Remember, if this is on, then this is going to be false. When that goes true, meaning that the carton has passed by the photo eye, the trailing edge of the carton has passed that photo eye, then that false to true transition increments the counter by 1. The count up bit here on the next scan makes this false. That resets the timer, the done bit's clear, and you're ready for another carton. All 3 rungs work exactly the same way. This is a very clever little piece of code. Study it closely, and remember that when you first look at this, you're going, holy cow, what count up? What's this? Done bits here, done bits there. I'm looking at the photo eye here, I'm looking at it here. Now, traditionally, if this were a 500 or RSLogix, it would look like this. I'll just go ahead and do this real quick, just for grins. Let's grab this, and this. Drag it down here. Because you can't put output type or execution things like timers and counter instructions in series in the 500. So this might work in 500 or RSLogix. However, I don't want to get off chasing a rabbit, so I'm going to get back on track here, folks. Do not convolute the learning process by adding what ifs to the system. Sufficient to the day is the evil thereof. We have held the I/O usage to a minimum to accommodate the simplest of lab stations. And I consider our lab stations as simple as you can get. An IQ6 XOW4, 6 inputs, 4 outputs, very inexpensive module. Now if you have an IQ16 and an OB16, good for you. You can hook up more inputs and outputs. You can have a digital field device simulator that has 16 toggle push button combinations and 16 lights on it. I found that any more than 6 inputs and 4 outputs, it gets very difficult to keep track of what you're doing. That's why I try to keep it as tight as possible. Now this is one of those logical approaches that you have to try online in the run mode to make sure you have understood the behavior of the count up bit, because we did not do the count up bit when we were doing counters. The 2-second debounce is there to eliminate double counting when an object or part bobbles at the PE, or like I said, your best friend walks by and passes his hand in front of the photo eye to be funny. Now the one thing that I want to really emphasize is object bobble. I call it bobble, wiggle. Remember that this code executes really quick, so the I/O update, depending on your RPI, which we have ours I think set at 20 milliseconds. If I go down here, go to properties, Go to connection. We're set at 20 milliseconds. Okay. Drag this back. That means every 20 milliseconds, the inputs are going to update the data table in the processor's memory. If you imagine a carton on a conveyor that starts and stops and jerks, and maybe when it comes off of one conveyor onto another, that it tips a little bit. Let's say the conveyors aren't exactly lined up perfectly level with each other, even level. So the carton bobbles a little when it first gets into the photo eye. So it could break the photo eye and then tip backwards a little bit out of the photo eye and back in the photo eye. I call that object bobble or carton bobble. Wiggle. Call it whatever flips your switch. Okay, so go online with your project and test the production conveyor part counters. We're going to pause for a minute. Make note that these switches, the entrance photo eye for conveyor 1, 2, and 3, local 1-eye data 1, 2, and 3, they're not used anywhere else in any other routine. So we can run this routine here by simulating the photo eyes being blocked and unblocked to test our code. So what we should see is that this goes on. If it's on for at least 2 seconds, then we count up. And then we turn it off. This resets and it's ready for the next carton. So let's turn on that photo eye. Now I'm only going to turn it on for a short time. That's input 1. See? I'm not letting it time out. 1 second. 1 1/3 second. Now I'll go the full 2 seconds. See? Conveyor 1 count 1. So anything less than 2 seconds, it doesn't count. Let's do conveyor 2. Push button in, out, in, out. You see the state of these two changing, right? That's the same memory location. What that means is that the switch in executes the first half of the rung, and once it's done, you let off. This goes true, counts up. The count up bit right here undoes the whole rung. You have to watch real quick. I doubt you're going to see it. No, all that you see is things go false and it counts up. Now we'll do conveyor 3, which is input 3. See, if you don't go 2 seconds, it doesn't count. Go 2 seconds, it counts up. Okay, well good, that worked. Says accumulate several counts on each. Make sure that they work individually and they do not interfere with each other. Now if you like, you can lower the debounce. I think I'm going to lower it to 1 second. Just because I'm impatient and I don't like waiting. Okay, there's a carton. There's a carton. Notice I'm holding down the photo eye in conveyor entrance 3, conveyor 3 entrance. Notice that the timer's done, it just sits there. It's waiting for that photo eye to go false, meaning that the carton has passed by it. When I let go, the carton passes by the photo eye and it counts up. It's now on the conveyor. So this code all works great. For now, we want the conveyors to run whenever their entrance photo eye is blocked. So we add an instruction as a condition for all 3 conveyors, as seen on page 238, 239 or so in your manual. So we go to conveyors, and we go to the first rung, and we add in, go to favorites, and then we add in PE, conveyor 1 entrance, right there for us. Now, for these other 2, variety of ways you can do it. I can copy that and then paste one there, paste one there, change conveyor 1 to conveyor 2, conveyor 1 to conveyor 3, and then finalize all edits. I think I'm going to move my online edit toolbar up closer to the top. It's annoying reaching down there for it. Okay, so now if the photo eye is blocked, meaning looking at the diagram in your manual of 3 conveyors, it's roughly on page 235, 236, something like that. If local 1 I data 1 PE, if it's blocked by a carton coming up and resting against the nose, the entrance of the conveyor, enough to block the photo eye, then that's what we have right here. So I'm going to turn this on, but I'm going to leave it on. I'm going to turn it on and then go to conveyors. The reason it's not running is because the system is not enabled. Technically, I would not have been able to get the photo eye blocked because nothing was turned on. So let's go back to main routine and push that button. What's wrong here is this is off. Remember, we deleted the logic that controlled it. So we're just going to turn that internal bit on and leave it on. Turn on our system enabled again. Now go back to conveyors. We'll go to production first, and we'll turn on input 1. Okay, so you can see it start. Now I'm going to quick switch to conveyors. Ready? Timing. Okay, now it's running. The conveyor starts running the instant that this photo eye is blocked. Now it's waiting for that photo eye to get unblocked. Okay, so the conveyor's still running, right? However, if I turn input 1 off, guess what? Conveyor stops because the photo eye is no longer blocked. Picture in your mind the conveyor. A carton comes up to the beginning of it, if you want to call it that, instead of the entrance. It comes up and it bumps up against the dead conveyor belt, but far enough where the photo eye sees it. And the photo eye instantly turns on conveyor 1, and the debounce timer is done. Picture the carton, it's moving. Finally, it gets all the way on the belt, and it clears the photo eye. The photo eye goes off, it counts up, and the conveyor goes off. Okay, everybody's with me so far, right? And we know that this all works because we tested all 3 of these. We don't need to test all 3 of these because they're so close to identical that it's ridiculous. We just have different switches. Switch 1, 2, and 3 turning on conveyor 1, 2, and 3. They represent the photo eyes. We're going to have some nuances come up as we continue with this little fictitious project, our little fun challenge, where we don't want the conveyors to run anytime the photo eye is blocked. We'll just wait and see those. If we're going to count the parts going onto the conveyors, it is just as logical that we will have to count them off of the conveyors when they leave to the next conveyor. So I'm going to have you modify your logic as seen on page 238, 239, and I will pause and come back. Okay, your code, your logic should look something like this. Now these 3, the first 3 rungs we already had. I added a 4th rung, but in rung 2, well, the second rung, rung 1, I added a countdown because when I count a carton onto conveyor 2, it's coming from conveyor 1, so I have to count down conveyor 1. When I count one from conveyor 2 onto conveyor 3, I have to count it off of conveyor 2, and when it leaves conveyor 3, you have to count down. The one thing that you may miss that is an absolute must, remember that it's the count up, the advent of the count up bit that resets this rung. Well, there's no count up instruction in this 4th rung, rung 3. There's only count down, so you have to use the count down bit. Now here you could probably use the countdown in these two and it would be okay, but we'll stick with keeping this code looking the same.